Awesome. So, hey everyone, thank you for coming to this session on building a multiplayer version of Space Invaders. I'm Srushtika Neelakantam. I work as a developer advocate for a company called Ably Realtime. Ably offers a real-time messaging infrastructure for any of your applications, things from live collaboration tools that you see in Google Docs to location tracking that you see in Uber type applications, or chat apps. All of that kind of functionality you can build easily with Ably's infrastructure. In my spare time, I volunteer with the Mozilla Foundation, where I'm part of the Mozilla Tech Speakers program. They promote web literacy through a bunch of volunteers like myself. So if you're interested in public speaking about the web, please make sure to check that out. I'm also a co-author of the book Learning Web-Based Virtual Reality. It talks about the A-Frame VR and WebVR libraries. Those are two really cool, frameworks for building virtual reality on the web. So if you're interested in that, you should check out the documentation, not the book. Don't buy the book because it's completely out of date. But those frameworks are really good. You can reach out to me on Twitter or email if you have any questions during or after the talk. So before we actually get into the specifics and details of the game, let's actually play the game together. You'll be interactively playing this with me. Before we start, a bunch of caveats. The game right now is capped at 6 people. You'll know why in just a bit. Also, please open the link that I'm going to share in a computer browser because I haven't yet added the controls for mobile browsers yet. And that's the link. I'm also going to share it in Zoom chat real quick. Okay, I can't see the chat option. Yes, there it is. So that's go.ably.io/play-space. That's the link. So I'm going to open it with you all. So you can see, I'll share the room code just so you can join the same room as I am doing. That's not my nickname. You will see a screen like this. Basically, add your nickname and add this room link, room code, please. I'm going to copy that also and share it in chat. And I'll wait for a bit for other people to join. Let's see what's happening. All right, we have people now. Awesome. Okay, because okay, I'm dead. That was too quick. Let's see what's happening. As you can see, basically 6 people because Pride Month, Pride colors. Let's see if anyone makes it to the end. The goal is to reach the other end without dying, and the ship moves randomly, changing velocity and direction every 5 seconds. Oh, there you go. Look at that. We indeed have a winner. Zara won the game. Mike is the first runner-up and Harry is the second runner-up. There you go. Awesome. Thank you for participating. Let me quickly go back to the slides to tell you more about it. So as you saw, basically the game is a very different version of the classic retro Space Invaders. Instead of being the ship, you're actually the enemy, and you play with other people who are connected to the game over the network. So let's get to the details of how this sort of like game is built, and how you can build other games like this, or add features to this particular game. So for any real-time multiplayer games, from what I've learned, it comes down to 3 core things. The first one is the assets, the sounds that we're playing, the avatars that we're moving. All of these things are assets. And these are your game objects. You can either add these as sprite sheets, images, or even draw these on the canvas from scratch. Then there's the concept of physics. Now, each of these objects interact with each other and different areas of the game in a certain manner. And physics is what defines that. For instance, in a game of Pong, depending on which area of the paddle the ball is hitting, it will bounce back with that particular velocity and in a particular direction. So all that is physics. Again, with physics, we can write everything from scratch because it's basically mathematics, but it's a lot of faff, and there are a bunch of libraries that will help us do that, as you'll see shortly. And the third and most important concept in a real-time multiplayer game is networking. As you saw, all of the players were playing together in complete synchronization. To make that happen, there needs to be constant communication between all the clients. So they can have the same game context, and no one is seeing something differently to the other player. So let's look at each of these in a bit more detail to understand how these are implemented. For assets and physics, I used a library called Phaser. It's a really cool open source library, WebGL library built for HTML5. I particularly used Phaser 3. The reason I mention is because if you're looking for some resources, Phaser 3 and below are completely different. Phaser 2 and children are completely, I mean, the syntax is completely different to Phaser 3, etc. So make sure you're looking at the right resources. But the good thing about Phaser is it not only lets you add the assets, play animation, sounds, and things like that in your game, but also it comes with inbuilt physics engines. And there's more than one physics engine, and you choose to use whichever according to the type of game you're building. What this means is you're not only easily saying, hey, render this asset here, play this animation here, but also saying when the bullet object collides with the avatar object, do this, and Phaser does it for us. We don't have to calculate, keep track of the movement, calculate if they've come into each other's territory, and what happens after that, and things like that. Other than that, let's understand the working of Phaser a bit um, to get a clearer idea. In Phaser, the way the game is rendered is basically in a canvas. So in a web page, you can have a div or any HTML element, and you can choose, you can tell Phaser, hey, render my canvas as a child of this element. And for every Phaser game, there will be a game config, which is an object which you'll start by specifying the different visual attributes of the canvas, the size, the border, and things like that. And then the most important thing that you'll send to this game config is an array of game scenes. Now, scene is anything that you visually see at any point of time. If, say, you're playing a game of Mario and you're moving from level 1 to level 2, the background is different, the objects are different, whatever you see and do is a bit different. So the first one is the first scene, and then you're transporting the character to the other scene. So that's the concept of scene, and every scene in Phaser is a class in itself that extends the phaser.scene object. And in this class, there are three default methods. First is the preload method, which lets you specify the various assets that you would be needing at some point in the game. So you're not wasting time to load them at the exact time when you're actually rendering it. There's no lag. You already load them, keep them ready to go whenever you need them. Then there's the create method. This is executed once for every scene that is rendered. So in the create method, you can do things like initialize variables, define animations, define sounds, and things like that. Then the most important method in this class is the update method. This update method actually runs in a loop for as long as the particular scene is rendered, which means things like bullets being shot or avatars moving. You can basically say, hey, every time you're running this loop, I want you to move the Y position of this particular object by this metric. So you saw the bullets being shot, right? So what I was doing is essentially saying, hey, just add the Y position +2 for the bullet. And because it's running in the loop, it continuously keeps on adding that, and then it seems like the bullet is just shot in the air, but it's actually just at the location, the Y position of the object or whatever is being updated at high frequency. That's about the Phaser part. Let me quickly show you in the code how this looks. So I have a bunch of things here. Don't worry about those right now. What we need to see is in the front end, I have a config object, like I was mentioning before. All the CSS attributes, things like that. The main thing is here, which is an array of scenes. I have a single scene because, hey, it's a simple game. This game scene is a class, as I said before. It extends phaser.scene, and in this, there's preload, which loads a bunch of sprite sheets, audio files, etc. There's create, which initializes variables, arrays, specifies animations, sounds, and things like that. And then there's this update method where I'm either showing a new, sprite sheet or updating the attributes of an existing sprite sheet, etc., according to the game logic that I've built it with. There are a bunch of other methods as well, according to what I want my game to do. But that's pretty much what we need to know for now. So going back to the presentation, um, now that the phaser thing is a bit understood, let's get to the networking part of it. Now, networking is really, it can be tricky depending on the type of game you're building. If it is just, a two-player game or a turn-based game, you could easily build a player-to-player, build the game on a player-to-player approach, where you basically have every player connected to every other player over the internet, and whenever one of these players emits an event, it is sent out to every other player. But as you can see, it can be a little tricky and unnecessary to implement this for a multiplayer game, because if every player is generating an event generated by each player is being fanned out to every other player, it very quickly leads to an n squared complexity, which is not really scalable for multiplayer games. So that's not really the best strategy. Furthermore, if you're having these players compute their own game context, it is quite possible that all of these different players are out of sync just due to a minor network lag, and we can't afford that to have that in this sort of a multiplayer game. Instead, a better strategy is something called client server. As you can imagine, there is a game server which holds the context of the game, the single source of truth at any point of time, and then it fans it out to all the players that are connected to it. Essentially, making sure there is a single context that is being maintained, and all of the players follow that context to render whatever the game state is at that point of time in the front end. Now, what's interesting is that how the server and the players are actually connected. So if we look behind the hood, you would think, hey, the basic thing is HTTP, right? Hypertext Transfer Protocol. You have a client, the server, set up a connection, send a request, and get a response back. In the Space Invaders game that I built, this server that I showed before is actually publishing a new game state update every 100 milliseconds, which means the frequency of communication is huge. So keeping that in mind, this sort of architecture doesn't really work for us, because it will lead to a lot of lag to just set up these connections, request and response cycles, etc. Instead, we need something that will allow the client and server to constantly communicate in both directions. So something of the sorts of WebSockets, which is a more modern protocol, it still starts off as a HTTP handshake, because not all entities that work on the internet support WebSockets. So in that initial handshake, it checks if WebSockets is a supported protocol. If yes, then the transport is upgraded, giving us full duplex persistent connection. Now we have the client and the server connected on an open connection, which stays open for as long as the app is running. Now, because the connection is open, the client can push, any of the inputs with the keys that you're pressing. The player input can be directly published to the server. The server can constantly keep publishing the game context back to the client, so they can render, the latest context, player positions, and things like that. And all of this communication can be high speed and still be possible. There is an equivalent protocol like WebSockets called MQTT, which suits IoT devices better, because it is much more lightweight, and hence it's suitable for battery and bandwidth constrained devices that are IoT devices. So WebSockets or MQTT or even SSC, if you're looking for subscribe only functionality, any real-time protocol would work really well for this kind of communication. But how would you implement a WebSocket server? You can write something from scratch, but why would you do that? Because it's such a faff, and there are a lot of open source options available already. I'm sure a lot of people would have heard of Socket.io. It is really popular. It's actually hugely popular in the Phaser developer community as well. But the problem with open source options is they won't really scale if you would like to use it in production. You'll have to, build a whole other distributed network yourself to, add scale to your application, and also add things like, message ordering, reliable messaging, and anything that you need for the kind of application that you're building. If it is necessary for every message to reach the clients, you'll have to build that yourself on top of these open source options. You can do that, or you can use something like a data stream network, which comes with WebSockets or other real-time protocols implementation, plus gives you all these add-on features that are basically a ready package for you to build production level applications that communicate in real time. In this example, Space Invaders, I've used Ably's real-time infrastructure. So to look at it a bit more in depth, in the client server architecture that I showed before, this is where Ably will sit. That is, the server and the clients will now communicate via Ably. Players will publish data to Ably, which will in turn publish it back to the server. The server will publish something to Ably, and that will publish it to the clients. This makes the client and the server completely decoupled, giving us a way to scale it as we want. Also, because every player is publishing data to the server and not to every other player, like we saw in the P2P approach, this approach scales linearly, and we don't have to worry about an n squared complexity. Right. So in this networking thing, how this generally works is using the publish and subscribe messaging pattern. What this means is every entity that is part of this messaging ecosystem, or the application basically that you're building, would either play the role of a publisher or a subscriber, or both. As you see in this example, there is a truck which is publishing GPS location updates that the customer's desktop and the customer mobile are interested in. So they are subscribers, and because they're already connected with an open connection, they basically get pushed that update from the server. They don't have to request that data. And you can also see the concept of channels, which means, in the whole application, you can define different groups of data, and you can define which participants are part of which groups of data, which channels. For instance, in this case, customer desktop and mobile are not actually part of job updates channel because they're not allowed to see that data. So you can differentiate, basically group different kinds of data into this concept of channels. This is a hugely complex diagram in the first look, but let me clarify it or simplify it very quickly to help you understand the game architecture in a better way. So what's happening in the game with all the concepts that I've talked about so far is, let's consider the scenario of two players. There is a host who is launching a new game room, and a player who is joining a particular game room using the code of the game room. In that scenario, I have the server. I also have multi threading implemented on the server side, which means every new game room is run on a new worker thread in Node.js. So what happens is, basically, a host um, uses a global channel to let the server know that they're trying to make a new room for other players to join. As soon as the main thread, the server thread, gets that information, it creates a worker thread, which then subscribes to death channel, player input channel for each of the players that are involved, and also a room channel specifically for the room that the particular worker is working with. Now, the room channel is where the server or the worker thread will publish all of the game state updates, which are happening at 100 millisecond frequency, if you remember. And player one input, player two input channels are used by all the players to publish their input updates. That is, if the player has clicked the left arrow key or the right arrow key and things like that. Then the death channel is basically to say, hey, if the host is killed because of bullet hitting the person, or if the player is killed because of the bullet hitting the person, basically any player, if the player gets killed, they will send an update to the server, which will then fan it out in the next game state update on the ABC room channel to the rest of the players. So they can then implement the same thing in their, they can basically render the latest thing that has happened in their screen as well. So as you saw, if a player died and an explosion animation happened, the same thing was happening for everyone else who was playing the game with me. This, ensures a really good synchronization and also decoupling of the server side and the client side completely, allowing us to scale. So let me quickly run you through this implementation where I'll just increase the font a little bit. Basically, what's happening in the server is this is the main thread. It connects to Ably global channel. There's a concept called presence, which lets clients know, which basically lets anyone know that they've entered this channel and have made themselves online. So whenever a player joins, the host would enter the global channel, and when that happens, the main thread will generate a new thread, and in the worker thread, it basically has things like its game room, the dead player channel, etc. It will track enters and leaves of the other players who are joining that particular game room, and then basically uh, publish the game tick every 100 milliseconds with the details of all the players, their XY positions, their alive or death info, etc. All of this packaged in a single update every 100 milliseconds to all the players. And these are the same channels that the players would be subscribed to, so they'll get that data pushed to them, uh, allowing them to render it properly. I'm not going to go into all the details, all the functions that are rendered here, but it is available on my GitHub uh, project, which is this link. And also I have a 4-part series which explains all of the details of what went into this game, the considerations, caveat at every stage of this application in this dev article series on dev.to, which is the second link. So feel free to check that out. And if you have any questions, feel free to reach out to me on Twitter or email, as I was mentioning before. That's pretty much for this talk. Thank you very much for listening.
Thank you, Srushtika, for that. That was actually really fun. And of course, I won. I'm a gamer, so I'm happy to have won the game. So just if anyone has any questions, please write it in the Q&A. But for now, I think I have a couple questions. So how do you handle, for example, if someone has a poor connection, how does this handle that?
This is not currently handled in this particular game, but the way you would handle it is with a concept called linear interpolation, also called LERP, lerping technique. Basically, what you do is you run the game 2 or 3 updates behind for every player, which means even if you miss one of the updates, you already have another ready to show it. Also, sometimes you predictively move the avatars before you even get a new update, just to say, right, it was going this way, so it must continue going this way. And this is actually also useful for even minor network glitches, which make bad user experience or something. So basically smooth that all up using lerping technique. There are a bunch of libraries that let you do that easily.
Okay, and how does this affect the user's input delay?
That's a really good question, which I hadn't thought about until now because I haven't implemented that in the game. But I will have to get back to you on that.
Okay, that's fine. Yeah. Oh yeah. Again, anybody, if you have any questions, feel free to ask them in the chat or the Q&A, and I'll make sure to ask them. So, what is missing from your browsers, from the browser API, that you think could improve this or make this better?
I mean, the whole phaser library is built especially for browsers, so I'm not sure I found anything missing for this game in particular.
Yeah. Okay, and when trying to learn about this topic, where would you suggest people start?
There are a bunch of YouTube playlists, really popular ones, where people talk about how to get started with Phaser 3 and the different things involved. The documentation I'm not a fan of because it's a bit confusing and they don't really have a lot of examples, but these tutorials are amazing. Also, this article series that I wrote, the second link, I've linked to a lot of other resources to learn about real time, to learn about different protocols, to learn about Phaser, how you can make your own assets or get free assets. All of those links are available in that series as well.
Okay, thank you. We have a couple of questions actually. So someone, Patrick O'Keefe asked, how do you deal with different levels? Can you have level 1 and to 1 to 4 like Donkey Kong, etc.?
Yes, basically, as I was mentioning, the concept of scenes, this what you saw is a single screen thing. And when people came to the lower level, I just switched the window to a different URL to show the leaderboard. What you can do instead is have multiple game scenes and switch from one scene to the next scene, and also have the data transported likewise, so you can continue the players playing in a different scene. This different scene will have different attributes, different animations, different backgrounds, whatever you want according to the concept. But that's essentially how you deal with levels.
Okay. And there was a follow-up question. Can you track which level different players are on?
Yes, you can actually, because even if you're using different game scenes, globally, you can track what's happening in which scene. Because, sometimes I don't know if you've played games like Call of Duty on mobile, there's a map on the top, which shows you where different multiple rooms that are, being played, where different, all of those people are. So basically, there's a global context, and then there's, game specific context, and that's how you can track what's happening.
And we have another question from Chris, and he asks, what can developer tools like, say, Microsoft Edge do for game debugging? Are there some things missing from the network debugging space?
I haven't used Microsoft Edge extensively, unfortunately, so I'm not in a position to comment on that. Sorry.
Okay. Also, another question. What is the limit to number of rooms you can serve per server?
The good thing is there is no limit. It can scale infinitely. The limits basically apply to my Heroku server because it's currently running on free dynos. But if I'm able to run the web server to, take infinite requests, I can basically scale it to whatever I want.
Okay, that's good. We have one more question from Devin. Is there any special kind of testing or special testing approaches you ended up using for this?
I think nothing really special, just the usual debugging tools so I use Microsoft VS Code. So it has really good debugging tools to debug the server side. Then I use Firefox debugging tools to debug what was happening on the front end, on the script side. So if you just add a bunch of takes, if you're observing different variables generally like you do for all the applications, that should be fine. Nothing special.
Okay. Yep, and I think that's all the time we have for questions. I don't see any more, so thank you so much for that. I'm sure we all really appreciated it. Thank you.
Cool, thank you. I'm gonna stop sharing my screen now.